Go ahead, Lily.
Good morning, good afternoon, or good evening, depending on where you're joining us from. We are thrilled to welcome you to the Cool Talk series, a new monthly webinar series from the Cool Coalition. From those of you who don't know us, we are a UNEP-hosted global platform of over 250 stakeholders who are collaborating on science, policy, and joint action to promote a comprehensive transition to sustainable cooling. Cooling is a cross-cutting challenge that demands urgent action across sectors. And through this series, we aim to elevate global voices, thought leaders, share key lessons, and highlight the critical steps needed to accelerate the transition to sustainable cooling. As the Secretariat to the Cool Coalition, as the head of the Secretariat for the Cool Coalition and the Global Cooling Pledge, we are committed to advancing the knowledge, technical assistance, and outreach to drive this agenda forward. Today's webinar, Cooler Finance, Sustainable Space Cooling for All, is co-hosted together with the Global Alliance for Buildings and Construction and the International Finance Corporation. It explores a flagship publication, Cooler Finance, which was a collective effort between IFC and UNEP and the coalition, Cool Coalition. And we're bringing together today this complementarity of perspectives. Global ABC is a global platform to accelerate energy efficient and resilient buildings to achieve near zero emissions in the building sector, while of course IFC is working on the private sector investment in developing and emerging economies, whose cooling team tackles the financial agendas to promote sustainable space cooling. Bringing these voices together is critical to actually achieve goals and to leverage the significant private investment opportunities that the report Cooler Finance has identified. Critically, the Cooler Finance report also highlights the need to increase the adoption of passive cooling strategies. Space cooling is the fastest growing of all cooling intensive sectors, almost tripling the investment opportunity by 2050 to 332 billion per year. And you'll hear more about that from the report later. The market for passive cooling in emerging markets is at 30 billion. It's already significant, but it certainly needs to scale dramatically to deliver near zero emissions. And in particular, to also deliver on the commitments in the Global Cooling Pledge, which was launched at COP28 with over 70 country signatories and 80 non-state actors. The Cooler Finance report actually lays a blueprint to implement this pledge. And today we will hear from experts on finance, on sustainable cooling, space cooling, to not only learn about the problems that we're facing, but also how to break through from the finance perspective and also from the built environment perspective. I have to say Cooler Finance is not just the topic of our webinar today, but it is really the defining issue of our time. Each year, greenhouse gas emissions rise and driving more extreme heat and leaving vulnerable communities struggling to survive. And that's while global temperatures are still below 1.5. Many communities are really unprepared for what's coming, and we really need a massive scale up of access to sustainable space cooling. So with that, I would like to hand it over to Rusmir to introduce our guest speakers and what will be a very important discussion on Cooler Finance. Thanks. Back to you, Rusmir.
Thank you so much, Lily. So you heard about this work across the series. We want to remind you that this webinar is being recorded. Lily, if you wouldn't mind going on mute at this point. So we are being recorded, and the recording will be shared hopefully in just a few hours with you. We'll put it on the YouTubes of the different channels so that all of this is available. During the talk, we will have some time for Q&A, but during the whole process, you can use the chat feature to ask your questions. And in the end, we will have some follow-up survey for you as well. So today is a really great lineup of speakers. Let me introduce first Jonathan and Ziep, one from UNEP and one from IFC, who are going to give you the quick welcome. And then we're going to talk to Genai and Bolivar. Bolivar is another organization from ACAIRE, who's going to walk us through the main elements of the program. So Jonathan and Diep, turning over to you for the welcome notes.
Okay, should I go first? I didn't.
Sure.
Really... Okay, thank you. So, hello everyone, greetings from Paris. So, I'm leading the buildings and construction team in UNEP, under which we have the Global Alliance for Buildings and Construction. And I'm very pleased today to collaborate, of course, with my friends from the Cool Coalition, who are together with us in UNEP and IFC for the School of Finance and Sustainable Space Cooling for All webinar that will zoom into the key takeaways for the building and construction community from the Cooler Finance report that was issued in September last year by IFC and UNEP's hosted Cool Coalition. IFC is a long-standing partner for us in UNEP, and I would say with Global Alliance that we started in 2015, they actually joined since the establishment of the Global Alliance for Buildings and Construction. And they are specifically bringing their experience and expertise with green financing for buildings, and more particularly, I would say, from their Green Building Certification Initiative, EDGE. And we have a long-standing collaboration, especially on the finance side, also under the Global ABC, where IFC is a co-lead of our hub on finance. UNEP, as the host of the Global ABC and the Cool Coalition, and IFC as our partner in both initiatives, share a common interest in advocating for sustainable space cooling through green finance. Ensuring comfortable indoor temperature is essential for the well-being of all people, as we all know. And last year, the Global ABC, together with the Cool Coalition, initiated the joint action group under the Global ABC, focusing on passive cooling, with a view to bring our respective communities together. On the one hand, the Cool Coalition's community committed to accelerate passive cooling to address urban heat. And on the other hand, Global ABC's community that is committed to achieve zero-emission, efficient, and resilient buildings. With this webinar, we aim to share the findings of the Cooler Finance report with the buildings community, and we will extract the essence of the sustainable space cooling, both passive and active key areas, and discuss potential financial schemes around it. We have also developed a fact sheet that summarizes the key takeaways from this report for the buildings and construction community that we will share and disseminate after this webinar. It will, of course, not be a surprise to most of you that we are strongly advocating for passive first, designing buildings that can ensure a comfortable temperature for its occupants with no or limited need for active cooling technology. By the way, they are designed and built is the best actually solution in terms of energy efficiency measure. People around the world actually used to build their buildings adapted to their climates and the climates they were living in. And this has changed, I would say, in the early 20th century when we found fast and efficient construction techniques for building high-rise buildings using steel and concrete, which we could ensure thermal comfort thanks to air conditioning equipment. But now we have realized the limits, I think, of these solutions that actually have brought us new problems, while at the same time, this way of building and ensuring thermal comfort for occupants has become the new norm around the world. And we must really now come back to solutions that are rooted in local climates and make construction techniques, technologies, and design that can limit the need for mechanical solutions. And this should be the new normal practice for all actors in the buildings and construction industry. So I want to conclude here, and I hope that this webinar will actually really encourage us to move for passive first and show that this is a solution and for which also the financial schemes actually already exist. So implementation has to take place now. Thank you. Rusmir, back to you.
Thank you. Let me turn it right over to Ziad.
Good day, everyone, and welcome to our Cooler Finance seminar. IFC, International Finance Corporation, has been a leader in the green building space for over a decade now. We're actually celebrating 10 years this year. And for us working in emerging markets in the global south, green buildings means sustainable cooling. This year, the EDGE Green Buildings Market Transformation Program at 10 years is boasting over 110 million square meters certified as green, which translates to about $110 billion in green finance and private finance enabled for real estate. Some of our key green markets like Africa and Mexico have already reached 10 million square meters certified. And Colombia, our biggest market, has reached over 20 million square meters. And in many markets like Colombia and Vietnam and South Africa, EDGE is the biggest green building certification program. In addition to our tools like EDGE Green Building Certification, we've been launching programs that combine investment and advisory for our clients, like the GRIP program for owners of real estate portfolios, or the MAGIC program, in which we work through local financial institutions to enable financing, to link a green building to financing. And many of our stakeholders and clients find the financing link very useful. I wasn't surprised at all that our Cooler Finance report showed that the majority of market growth for sustainable cooling is in buildings. After all, almost everything that we humans do in building is in buildings. We live and work in buildings, we go to school and get hospital care in buildings, we enjoy arts and culture in buildings, and even our farmers use buildings to take care of animals and plants. That's why cooling for green buildings is one of the 5 main sectors of our sustainable cooling strategy, which is a 5x5 plan to address 5 sectors where cooling is needed the most through 5 modes of engagement. Not difficult to forget when it's a 5x5x5. Rolls off the tongue. I'm excited to bring IFC's wealth of expertise in this sector so we can jointly scale up investment and help cause a sea change in this market. With that, I'll turn over to Rusmir. Thank you.
Thank you so much for great words of welcome from the 3 of you. You can probably go off camera because we'll turn to Ganai for the real meat of the exercise, follow up by Bolivar, who's going to talk a little bit more about the innovation and cooling. So Ganai, over to you. For some reason, we cannot hear you now. Oh, you're still muted, Ganai.
Thank you very much, Rusmir. Thank you. Hello, everyone, and good morning, good afternoon, good evening, according to where you are. And my name is Gennai Kamata. I'm from UNEP. I'm currently working for the Global Alliance for Buildings and Construction, or Global ABC, and also Cool Coalition, because the both common topics is about the passive cooling, which I'm currently working on. And then today I'm going to talk about the finance on the sustainable cooling, and I'm going to cover in the first part. It's more. I'm going to speak on the why we need sustainable cooling in the first part. Then I'm going to talk a little bit about the sort of the solutions and what we should do from the finance perspectives. So let me go to the next slide. So why sustainable cooling? So as you all know that this is a critical topics that we need to address. People in the developing countries started to migrate to the cities to have a better living life, and where people need more and more buildings to live and work in. And in that sense, we need more and more floor areas, and by adding additional buildings in the cities, then people started to use more and more space cooling, which leads to the higher energy consumption and also the GHG emissions. So when we use the cooling strategies, this needs to be very sustainable. And when I mean the sustainable space cooling, it basically covers the passive cooling and also the active cooling and energy, like energy efficient appliances such as the inverter controlled air conditioner. So when I mentioned the increase floor area, this phenomenon is critically happening in Africa and China, India, and other Asian countries. So this is just because these regions are having more and more population and urbanization. So next slide. And when I deep dive into the topics, first I want to mention about the energy consumption and GHG emissions in the building sectors. So this data comes from the Buildings Global Status Report, which was just recently launched this Monday. And then in this report, it's basically explained that the 1/3 of the global energy consumption and CO2 emissions are actually attributed to the building sectors. And in the breakdown, we have more operational emissions than embodied carbon. Operational emissions reached 9.8 gigatons, while embodied carbon reached 2.9 gigatons. Even though it is said that embodied carbon will reach to the same level of the operational carbon in 2050, we still need to address operational emissions through designing the better buildings. And the space cooling is one of the critical topics that we need to address to reduce operational emissions. And as I mentioned, this is the global status report from the Global Alliance for Buildings and Constructions. And so this annual report basically covers the progress of the building sector in terms of policy, finance, technology. But one of the critical topics is about cooling. So it introduces one data saying that cooling remains the fastest growing end use in the building sector, particularly driven by the Asia-Pacific region, having increased at the average rate of 4% per year since 2000. And from the Cool Coalition perspectives, we launched this Global Cooling Watch report at COP28, as Lily mentions in the first place of this webinar. But it basically introduces a pathway towards net zero emissions in the cooling sectors. And one of the focus area is about passive cooling. And it introduces one data that says passive cooling can reduce cooling demand by 24% by 2050, saving up to $3 trillion USD in equipment costs and 1.3 trillion tons of CO2 emissions. So this space cooling is very significant areas to address. And from the report, it's estimated that in 2050, as a BAU scenario, we are emitting 6.1 gigaton CO2 emissions. However, if we take measures such as passive cooling or energy efficiency in appliances, as well as the faster phase down of the HFC, we can actually arrive at 2.3 gigaton CO2 emissions, which is the 60% reductions from the BAU scenario in 2050. And it can actually save 3.8 billion tons of CO2 emissions. And now let me focus on this cooler finance report that we are gonna feature in this webinar. So this report was published last year. And the main topic of this report is to size the market opportunities that sustainable cooling represent across emerging and developing economies. And it can also bring attention to challenges and opportunities to financing sustainable cooling in the context of these countries. And also it can provide a blueprint on how to finance sustainable cooling. And let me introduce some of the data that we found from this report. So the entire cooling market is currently about 300 billion. As you can see in the graph, in 2023, it's 272 billion USD. However, because of the increasing demand of the cooling, it's estimated to grow up to 600 billion USD by 2050. So this is going to be a very significant growth. And if you look at the trends by region, due to the urbanization and the increasing floor area, the South Asia is expected to grow 4 times larger than today, and for Africa, it's expected to grow 7 times larger than today. So these regions are significantly important to look at. And also, if you look at the breakdown of this total cooling market, space cooling actually accounts for the half of the total cooling market. If you look at the graph in the middle, in 2023, the space cooling market is 129 billion USD. However, it's estimated to grow 332 billion USD in 2050. So this is going to be 3 times larger, and it's actually larger than other cooling sectors such as mobile cooling or refrigeration. And if you look at the space cooling market in itself, active cooling actually accounts for almost like 90% of the space cooling market, while passive cooling is 30 billion USD. And also, if you look at the building types, like new buildings and retrofit, for the new buildings, currently the market size is the 15 to 25 billion USD per year, while retrofit, like existing building, is 10 to 15 billion per year. So now active cooling accounts for most of the share of the space cooling market. However, in order to achieve the net zero emission society, we need to make sure to accelerate passive measures because this is a low-hanging and cost-effective measures. And also, the benefit of the passive cooling is actually you can save the electricity cost in the operational phase of the buildings. So if you accelerate sustainable cooling, the consumers in the developing economies can actually spend 6.4 trillion USD less by 2050. So now let me deep dive into the more of the solution part of the passive cooling from the finance perspective. First, let me a little bit explain about what is a passive cooling. I think most of the audience already understand this concept, but basically passive cooling is the measure that try to reduce the dependence on the active cooling, such as air conditioners. And these passive cooling measures are very have been with us since old times, like from ancient times. So this is not the new technology. This is more of the technologies that are already available. So in that sense, it's very cheap. It's not a new technology. So it's easy to adopt into your building design. But the problem is that these passive measures are not necessary. The architects, design professionals are not necessarily understand this concept, unfortunately. I am an architect, and then I also had education in the university, but most of the architects are interested in how to design the building as beautiful as possible. Like they only look at aesthetic aspects, and they don't have the opportunity to learn about this kind of energy aspect. So that's why in reality, even though these technology are there, architects don't often understand this technology and don't reflect this technology into their building. And that's why it's not spread well. However, it is a time to raise awareness of the importance of this technology because, again, it's very cheap and actually cost negative in certain situations. So when I speak about the passive cooling, how this passive cooling could be financially beneficial. Let me explain with this graph. So there are two main black lines. One is the dot black line, which represents the cost of the traditional building, while the black line represents the cost of the energy efficient building with passive cooling. So as you can see, in the early design phases, such as concept or planning phases, the energy efficient building costs slightly higher than the traditional buildings because of the because this building needs to incorporate passive measures such as double glazing or highly insulated walls. However, because of the benefit of passive cooling, if you start living in a house, you can actually save the operational cost. So if you compare the operational cost between the traditional building and the energy efficient buildings, you can actually see the gap on the right top in this graph, that this gap is getting wider and wider as you live and the building gets ages. So I mean that if you invest in the initial phase of the building design, you can actually, even though it was a little bit expensive than traditional buildings, but you can actually gain benefit in the operational phase. And then this is very important because the buildings last like 50 or 60 or 100 years according to the type of the structure. Yeah, if it's a concrete, it's definitely last 100 years. Then in that case, this gap would dramatically become wider and wider. And people, if you live in a traditional building, you have to pay the tons of energy utility cost compared with a green building. So that's why we need to look at the early design phases. Now, actually, thanks to the IFC, nowadays we have a great tools called Edge software. So this is very useful in a way that architects and developers actually assess the energy efficiency and CO2 emissions of their buildings in the design phase. So it actually covers not only building like operational energy, but also the water efficiency and more of the embodied material aspect. However, today it's important to make sure that this is actually gives you the idea of how to reduce the energy consumption and CO2 emissions from these tools. Yeah. And it's just because this can allow developers and architects to simulate return on investment. Because with these tools, you can actually estimate how much is the incremental cost is versus how long is the payback period. So that you can sort of understand the cash flow of the entire period of the investment, and which works very well to convince your consumers maybe in the future. So also it can give you a lot of parameters such as the building typologies and floor areas and stories and occupancy patterns and densities and climate zones, etc. So this tools is actually applicable to like all across the world. Wherever you build the buildings, you can use this tool to estimate, to calculate the energy efficiency and the cost implications. And let me quickly explain some of the examples. So this comes from the Indonesia. So with this tool, we understood that these buildings is actually energy efficient and cost benefit. So this is the 373 houses in 2,600 hectare development. And these buildings actually incorporate window to wall ratio of 70.5%, external shading, insulation in walls and roof, and natural ventilation. And with these measures, you can actually get the incremental cost by 4.70%, which is slightly expensive than the conventional buildings. However, you can actually get a payback period within 2 years. It's just 1.8 years. So that means that after 2 years, you can actually benefit financially compared with the traditional buildings. Then you can get the cost savings by 30%, which is equivalent to 41 low-income houses annual energy consumption. The point is that this housing is not only available for the high-income population, but also the low-income populations, if the developers can explain very well, not about the starting cost, but also the operational cost. And if the consumers understand this return on investment concept, they are more likely to buy these houses. And this is another example. Again, this is the 19 premier service houses in Indonesia. And with the IFC Edge tool, it's calculate the buildings actually incorporated window to wall ratio, shading, insulation, natural ventilation, and the tool actually calculated incremental cost 3.58%, and the payback period is just 2.4 years, and the utility saving cost is 80%. So this is very useful tools to understand the cash flow. And finally, let me highlight our UNEP passive cooling project in Cambodia in collaboration with UNESCAP. So we, Cool Coalition and Global Alliance for Buildings and Constructions, are working with the Cambodian governments to enhance their policies and integrate passive cooling strategies into their codes and regulations. And this is one of the demonstration projects to make a case for passive cooling. So we partner with the local Cambodian developers, which is called Urban Land, where we had a courtesy to use their property to test the cool paint. And so this is a photo that they are painting on the roof, and see the comparison. If this the comparison, the roof with the cool paint, the roof without the cool paint, then see the comparison. And then we actually understand that, yeah, apparently the cool roof can give us the lower temperatures and more summer comfort. And we are doing this using this monitoring equipment installed inside the building on the ceiling, as you can see in the photo in the interior. And with this data, we are actually still monitoring the data result of it, but this is going to be available toward the end of this year, which we hope to feed into the Cambodian building policies and regulations in the future. And one more thing from this Cambodia project. So we, UNEP, actually in collaboration with UNESCAP, published this passive cooling compendium in Cambodia. So this basically explains not only about the variety of passive cooling measure which can be available in Cambodia market, but also it explains the cost benefit. Like, yeah, so for example, this is the typology of the window frame. So you can understand how much performance you can get from choosing different frames, such as wooden frames, plastic frames, and aluminum frames. And then you can see how much you value, and also you can understand the cost implications from these products. So if you are interested in, please look at this document. So this is the end of my presentation. So thank you very much for listening. So now I over to Bolivia for the next.
Bolivar, I think there were a couple of great questions and we seem to be good on time. Ganai, if you stay and we can answer them together. One of the questions was, how can innovators in passive cooling join forces with the Cool Coalition to pilot new technologies and contribute to the mission? This is from Sumitra. I have some thoughts. I wonder if you do as well.
Yeah, thanks, Lucia. Thanks for the questions. And yeah, we Cool Coalition and also the Global Alliance for Buildings and Construction collaborate with many manufacturers, many private sectors to understand their products and how these can be applicable to our project. And then, yeah, and we actually, as Jonathan mentioned before, we have the passive cooling working group where we provide opportunities for such private sector members share their products and with others. And then we can, accelerate the knowledge sharing. And then maybe if the needs matches, we can discuss further to actually apply these technologies. So first, I encourage you to join this passive cooling working group. We can, of course, share with you the contact, how to join us. But maybe Lusmia, if you have any more insight on this.
And we sent some more information on how to be in touch with the Cool Coalition in general. There are sort of two questions that came. I think I can answer them. If you want to bring up the EDGE slide, just a few back. So one of the questions was about CO2 emissions and how does energy efficient cooling technology reduce CO2 emissions? You actually can model that using the EDGE tool directly here. It's going to be obviously different between hotel versus a home versus, let's say, an offices. And the idea is that we look at the efficiency of cooling and GHG emissions. It's not really just about CO2 in two ways. Through a more efficient system, you're using less electricity. That electricity is typically powered by a sort of a dirtier electrical grid. And so efficiency in appliances reduces the need for more electricity. The second part, and this was related down below, I think was a question from Alan, is about leakage from the GHG gases that are used as coolants. And there is an effort to change those as well. I will post in the link in just a second as Bolivar is talking, our EDGE assessment for coolant gases that can be used in the systems that have this, what's called the lower global warming potential. So again, remember the CO2 is being or GHG is being calculated on two of those things. And then the one other question I think I'll answer now before we turn to Bolivar really is about the costs. So one of the things, again, you can see is that we launched the EDGE tool from IFC really in order to help the designers and developers calculate the upfront cost. I forget who had asked the question, but you are correct that implementing both passive cooling measures and more active cooling measures or other efficiency measures at the time of design is typically cheaper than doing a retrofit. And this is why we're really focusing on emerging economies where the speed of construction still continues. There's very little retrofitting happening, let's say in places like India, China, Africa, that it's really new build. And so we want to ensure that that new build incorporates all of these actions. IFC is going to be launching new versions of the EDGE tool that will make the retrofit aspect easier to calculate, but we can help you do that part. There are EDGE officers and EDGE experts who are available around the world, and they can be contacted to do that. And again, I'll post in the chat their ways that you can find this in the country, or you can be trained in EDGE as well. The last point I'll make is from Clara. She talked a lot about the difference in construction costs between a homeowner and a home builder, right? Because the home builder is the one that takes up the costs but passes on the benefit to the homeowner. We actually did this as a series of articles. I helped write them. There's one that I wrote specific for Africa. Again, I'll post it in the chat, which is the idea that most developers consider green as just a sunk cost, right? If they include the efficiency, it's gonna raise the cost, and that's just gonna eat up into their margin because they probably cannot sell at a higher price. There are other ways that developers can benefit, and one of the main ones is actually faster sales. So they can differentiate themselves with a different product on the market, and that product, and we have data that shows that it actually sells faster, 20, sometimes 30%. And so the developers can monetize that benefit. There are government incentives, there are banks that are providing lower interest rates to projects that are being that are having green certification. And so actually one of our webinars somewhere down the future could be that we look at the home sector specifically, because this is one area that IFC has done a lot of work. So hopefully, I think I answered a few of the questions that came out. They were all really great. Again, we're gonna, this is being recorded. We'll share the presentation, and you'll also get the fact sheet from the report, and we'll try to include a few more links given the questions that came up today. Thank you to Genai for now. So Genai, if you fast forward, and then let's see if we can have Bolivar to rejoin, turn on his camera. Bolivar, would you like to present directly?
Okay. No, I prefer that Genai support me.
Okay.
Are you?
Sure.
Thank you. And good morning, good afternoon, good evening for all of you. Thanks, Ruthmir, and all the team of EFC and Cool Coalition for this invitation. Do you hear me well? I am sure to. Yeah. Okay. In this section, we will explore some technologies in HVAC that maximize energy efficiency, reduce operational costs, and contribute to sustainable development. This presentation is based on real projects, financial data, and emerging trends in high-performance building technologies. My name is Bolivar Monroy. I'm a technical director of ACAIRE, but I give you some points about ACAIRE. We work since 1981. We are a non-profit organization focused on HVAC and district energy sector in Colombia. We develop training, exhibition, and projects. And the last project that we support the TechEmerge cooling in Latin America. The next slide, please. But Gina give us a lot of information for this topic, but I will remind some specific data. HVAC systems accounts is nearly 40% of a building total energy consumption. That you see in the picture, the use of cooling system is important. Most of the potential of these savings opportunities will be in the operational stage. Another point is an evolution in our regulatory trends. We have a regulatory push within a mixture of voluntary strategies that Genai and Ruthmir mentioned. Edge is increasing the impact of each country, and new laws for our countries that is obligatory. In terms of financial impact, globally, inefficiency systems operation costs a business over 16 billion per year. This is a lot of money that we lost. But today we have a challenge to invest in technology that can avoid indirect emission that you see in the picture, and they are related to the use of energy. And the same time that you mentioned in the previous conversation, the direct emission related for use of refrigerant. But the good news is that we have the technology to make this transformation possible. Some of the trends that suggest we have in this moment is the automatization, optimized HVAC performance, for example, with technology, with EOT, with artificial intelligence, the expansion of thermal energy storage, district cooling systems, and adoption of low and develop of the system on low GWP refrigerants for sustainable compliance. And now let's see some of them in real projects. This is a summary. You can see in this slide a summary of technologies and the project that we explore so quickly. In the next days, we will send you, I think that is hours, we will send you this information and you can review later. We have a mixture of different users, and the last one, it was a project developing the TechEmerge sustainable cooling strategy. And the next slide, we have our first project, Singapore's energy system. This is a mixture of a smart HVAC system, intelligent artificial driving, and building automatization and the use of district cooling. Despite the need of high efficiency HVAC, many buildings still operate outdated systems, leading to higher maintenance costs and the opportunity to increase the energy performance. However, advance of intelligent artificial intelligence, smart sensors, district cooling systems, and the real response of energy demand provide solutions that significantly reduce the energy use and increase the ROI in these projects. This graphic shows all the information that Singapore used to decide the information is useful to determine how the energy system adapt the operation and adjust the system to improve the performance. The next project is now let's dive into a specific technology that we are the revolutionizing energy efficiency in building. We explore a retrofitting iconic building, the Empire State Building in New York. This project was promoted by law change that the past 5 years, New York improved the restriction to emission that each building can develop in the city, and the opportunity of financial support for replacing and updating the system. As we can see in the graph, these projects start with the optimization of water circuit, then the implementation of technology that allow the reuse of energy, and later the implementation of heat pump to electrify the water or heating process. Next slide, please. You can see in this graph the difference and the before the building, after the technology appliance. You can identify the main equipment that was used. We can see how the cooling and the steam system are integrating, looking for the energy energy optimization. The total invest of this project allow a ROI of 4 or 7 years, depending on the operation. You can see the implementation. For example, the air source heat pump, some specific heat exchangers to improve the energy change for cooling and steam system, and some specific relation of both systems. For the next project, we have an opportunity to use, I think that is a specific retrofit related of use of chillers and the magnetic bearing chillers and next generation of refrigerants. Not only changing the entire segment result in a reduction of energy consumption. Chillers have been built in a compression system, and magnetic bearing chillers are not available with low refrigerants. According to the information reported by the U.S. Department of Energy, the use of this equipment reduced energy consumption by 65%. If we look the graphs, we can see a turbocore technology. By using this type of bearings, significantly reduce the consumption and increase the performance with respect to the load. You see the turbocore graph, that is the blue one in the upper graph, and the lower graph, you can see the operation is increasing the relationship kilowatts and ton of refrigeration that is increasing is the only technology that increase the performance. For the last one project, it's a mixture of different combination and different things. The first one is application of BIM methodology to design and build the building. The second is the mix of technology of passive and active strategy. And the third one is the control in automation with EOT and a lot of sensor for each floor and office. And the last one is the use of photovoltaic and geothermal energy. The result of this project is a 18% lower demand versus an conventional office. This project is an opportunity to identify some characteristics related to orientation, natural ventilation, a use of geothermal energy, and noise control that we can replicate in our countries. Next slide, please. This as the last project that, remember, is not only the change of the equipment resulting in a back energy consumption. This project born in a mixture of technology and a new business model. That combination of technology, first one, the EOT, second, the owner focus of EIQ improve, third, the optimization project process with new cooling towers, and fourth, the support with a good process of weather treatment. The results are a reduction of 16 or 18 energy, more or less 18 million of saving per year. And to finalize this part, I want to talk to action in 3 specific activities. The first one is assets. Assets you're building HVAC efficiency today. You must to know how much energy you building consumes in the case in the existing buildings. The second is explore financial incentives and cost saving solution. Don't worry about the money. This is not a problem. If you have identified the opportunity, you have a lot of financial tax incentives and other mechanisms to support this project. The third one is smart building technologies for long-term sustainability. You must choose technology to a long term. It's not for today, it's for our future of the building. And for continuous to the next topics, I want to show some the next call talks in April 2. Is that, I think that is the next slide, please. And I want to invite all of you for the next cool talk next 2 of April. We will explore how cooling as a service can accelerate market transformation and support climate commitments. Finally, Rudmir, I back to you from the final points and question and answer.
Great, that was really wonderful. I think what you hopefully saw from our presentation that we gave you basically a survey. So you saw some projects that were implementing this work in low-income housing. You saw some very high-end projects like the Deloitte building and others. Obviously, maybe innovation and others is happening more in the commercial space, and the low-income space is maybe implementing some of the more the passive cooling strategies, but both are possible. I have a few quick announcements, and then I'm gonna turn it over to questions to you all. So one of the questions was, yes, we will be sharing the copy of the webinar presentation that will happen later today. Unfortunately, we're not issuing a certificate of attendance for the webinar since it's just a webinar in the end, but maybe that's something that we look into for the future. And I will once I start with the questions, I'll drop in the chat our survey. You can point your phone to the QR screen and get the survey going. It's just a few questions in between. This is a good question I think both Bolivar and Genai could answer, which is, how do passive cooling strategies, especially around natural ventilation, combine with more efficient HVAC system? I just lost that. If developers design for passive, but homeowners later install HVAC, how will this play into their efficiency and actual energy consumption? HVAC systems are not only used to control temperature, but also humidity, especially around coastal areas. Again, I have some ideas, but Bolivar and Ganai, anything from you?
Okay, for the first question, I think that the passive cooling strategies, particularly the natural ventilation, can significantly reduce the use of HVAC system. But most of the information is to reduce the cooling loads, improve the indoor air quality. I think that is a perfect combination between the technology that you can develop a project with a low energy consumption and maintain a good indoor air quality forever. But if the passive design is not related with the HVAC system, is not the best option for the new projects. We think that this efficiency reduce the opportunity to improve our buildings, our houses, that in the passive strategy that we see in the previous presentation, we see a lot of opportunities to reduce the energy consumption. But this is a mixture of a good relationship between the architects, the mechanical engineers, the civil engineers, and we have a common language that is the sustainability. I think that is the perfect situation, and you see the tools that Edge is a good tool to prove, to adjust some specific characteristic that the project has.
Clara, I think the answer that I would give is that if you go to a system like Edge, you will actually see that it's a menu of options. And again, as Bolivar said, it's about the designer and the architect in the beginning understanding what are the things that would make sense for that particular climatic environment, right? So if you are in Ghana, where it's 100% humid, natural ventilation may not be the thing that you're going to do. What you can do there is prevent the sun, from coming in and sort of like beating down on the building. So the idea is that we suggest passive measures to start with, but they may not be where you end up with. And the Edge system has a concept of virtual energy for comfort, with the idea that we want the inhabitants of the building, whether that's an office or a home, to be comfortable. And we also can model whether or not they're eventually going to have air conditioning. So Edge can help you not only simulate the temperatures as they are today, you actually can override the assumptions and create a model that tells you, in 5 years' time, if the temperature is hitting 40 Celsius, or, in India, it's going to be 50 Celsius, what is that cooling load going to look like? And are there other strategies that you can propose to make that better? You can also model electricity prices. So in places like Pakistan, prices went up 3 times. Malaysia, I just traveled there. They told us that the government is reducing the subsidies for the electricity, so the electricity prices will go up. All of that is going to go into the business case. So one of the messages that you'll see from this particular talk is we're really focusing on financial aspects of the technical implementation and talking to you around the issues of payback period, business case, things that are going to make the decision makers do that particular action.
So
okay.
Maybe.
Yeah, go ahead, Ganai. And there's a lot of great questions came up as well.
Yeah, thanks. So thank you. Yeah, from my side, I just want to mention that the building should rely on both passive and active solutions we can't rely either of it. I mean, these are set of the solutions. And if you look at from the developer's perspective or house owner's perspective, like a client perspective, you are encouraged to discuss with the architects and engineers, because architects and engineers not necessarily talk to each other so often, even though it's necessary. Because the architects look at only passive, basically, and while the mechanical engineering or electrical engineering look at the HVAC system, more like appliance side. So these two peoples need to collaborate to each other. And this is where we, Global ABC and Cool Coalition can support by providing the platform to all the building and cooling stakeholder to join, to discuss and exchange their opinions. So we really welcome you to join this platform to accelerate the collaboration. But thank you very much.
Excellent. There's a question from Juan Ignacio on the cooling as a service financial model. I think, Juan, I would recommend you join the next webinar where this will be impacted more. One of the things that I am seeing from cooling as a service is this idea that much like you would get electricity and water as a utility, companies are starting to treat cooling as a utility. And so they're outsourcing this to somebody that ultimately knows to do it better, right? So instead of you owning your own chiller plant, it is maybe more efficient to give it to somebody who's a specialist, pay them a set fee, and then they are incentivized to make that ultimate appliance better. That's sort of one of my kind of main messages that I saw, but we'll hear more on the next webinar as well. One of the other questions was from Juan Ignacio, which is, are there good practices in developed countries that could be shared with emerging countries regarding investment and project development? I think that was part of the idea around the sharing these case studies. The other part is really about policy. I think that the developed countries are much more advanced when it comes to green building codes, which then raise the kind of the bar for everyone. What we saw with IFC is that emerging economies typically don't have the ability to enforce the building codes. And so IFC has done a lot of education around structuring incentives, public policy incentives that, again, developers can monetize, right? Faster permitting is something that doesn't cost a government anything, but it's something that a developer can very much monetize. So if you have a country that would find it difficult to enforce a mandatory code, they could launch public policy incentives, even those non-fiscal ones that could be really useful. So I'll include our thinking around how to design public policy strategies. I'll send that as a link as well. Let's see, we have a comment from Dr. Andreas from Guidehouse. One of the beauties of passive cooling strategies in general is that it will increase the efficiency of HVAC equipment. Oh, maybe it's just a comment. It will reduce the necessary cooling load. So that's exactly what Bolivar said. Sorry, I'm kind of reading through in this part. Hassan has a question. Could we have a documentation of passive cooling? So Ganai, if you want to send that to me, all of the different case studies, including the Cambodia one, I think we have the links to the projects. Oh, perfect. So we have it here as a link, and I'll in the recap email, we'll send it as an explicit link so people can find out what it is that has happened. Let's see. There's a question on what is your experience, thoughts about using water as a universal natural refrigerant in heat pumps to complete passive cooling spaces? Maybe Bolivar, you would best answer that one.
For example, if you pass to the Edge project, you can find some information about the use of only water for heat pumps. They develop a strategy to use the geothermal energy to the systems. And probably we need some specific refrigerants to develop the heat pumps. The different heat pumps that we have in the near future is related with some refrigerant. And in some cases, for example, in the market of the US, we have a lot of technology uses natural refrigerants, and not only water for these types of technologies. And I think that in Colombia we have, for example, some specific available technologies of heat pumps in with the low refrigerants. I think that is probably we need some more specific technical knowledge to develop only water, but we need to use some refrigerants to apply the heat pumps.
One of the things that you will see, and again, in the links that we provided, Bolivar mentioned IFC's TechEmerge program. So TechEmerge was a piloting program that IFC ran for a number of years. It eventually evolved into the cooling initiative that I am managing right now, and you saw the link for that. So TechEmerge piloted a few initiatives that used water in a more sustainable way by allowing it to be cycled many, many more times rather than, sort of just once or twice, using cooling towers that where the water didn't have to be treated chemically, with the idea then that water can be used for irrigation or really, sort of for other purposes as well. So I think the key issue with water is ensuring that we don't just sort of replace consumption of energy with consumption of water, because water, there are many, many water stressed areas, and to be honest, making water can be a lot more complicated than making energy. But so you will be able, when you click on the link, and maybe again I'll send that in the recap email, I'll show you the case studies that we had done through the TechEmerge program, which again can be lots of interesting pieces. Let's see. We have a question from Iris. Again, maybe I can answer this one. Does EDGE allow simulating the impact of annual temperature of 10 years? So Iris, the answer is yes. You can override the temperature data for as many years as you want. We are trying to incorporate and kind of link the different sister instruments that IFC has. So we have another instrument called the Building Resilience Index. BRI helps more with the disaster impacts of climate change, so think storms, flooding, and others. But we are gathering more data in there that's going to show the increase in temperatures as well. And we have another tool called the I'm messing with my name. It's one of the climate resilience tools that IFC has that also shows the projected increases in temperature. So if EDGE doesn't have everything all at once, you can kind of get different pieces of data and put it there. Remember, you can do both increase in temperature and increase in energy prices, both electricity and cost of gas and diesel. Let's see. Any case studies documented with the use of evaporative cooling methods as a passive cooling for large building space? Bolivar, you may know more. I think TechEmerge has some, but I'm not sure if you have a little bit more information.
Just for example, for LATAM, we have a project that we use evaporative cooling. This was a technology developed for a company in Colombia and Indian company. That is a good example that this mixture of knowledge into two different regions develop a good opportunity for one technology that can support. That is all the information in the TechEmerge project that you can find in the webpage.
I think those were all of the questions.
So
go ahead.
Can I come in, Lucia? Thank
Please.
you. So Yeah, about the evaporative cooling. So actually, as I mentioned, we have the passive cooling working group, which is jointly established by Global ABC and Cool Coalition. And then we are currently discussing this topic in our webinars. I just dropped the link in the chat. So, but in the previous webinar, we discussed about the nature-based solutions, which also related to the evaporation of the water from the vegetation and green element. So we basically invite experts to discuss these topics, and we are happy to share more content through this working group. So I encourage you to join this working group to understand this concept much more. And actually, we are also planning to develop the passive cooling guidelines towards COP30 with this working group members, where the evaporative cooling is one of the critical topics, because we hear a lot of opinions from the developing countries, which are the humid. In the humid region is not necessarily the country that evaporative cooling could work, because it's already humid, and it might be only applicable to the dry regions. However, if you look at Singapore and other Asian countries, there are many, green facades and green roof solutions are already there, and it's actually contributing to reducing the cooling demands and GHG emissions. So maybe it's just because of it's a matter of the selection of the species to really make it work. So we are discussing that kind of technical things in this community. So please feel free to join. Please reach out to me so I can put you in the mailing list.
Great. The only other, I think we are at time. I think if you just want to show our thank you slide, one of the things I think you will hear from me is there was a comment made by our colleague who works in housing, and she worked with developers of low-income housing in Haiti. And what they told her is that, they have been doing construction really on kind of almost on autopilot, because they thought that they knew what they had to do. And going through a system like EDGE really forced these developers, even of the low-income housing, to sort of stop and think, am I doing what's best for my environment, or am I just sort of on this autopilot and kind of doing things as I thought that it can be done? So I think what you hear from today is, one size doesn't fit all. That's true for finance. That's true for technical measures. You'll hear a lot about this idea of having to combine passive and active. But I think the call to action to all of you is to sort of rethink what you're doing and to see if you can do it better. So again, I'll turn it over to you to close.
Thank you, Rusmia. So thank you very much, everyone, for joining this webinar, despite of the time difference. We are really happy to have you all from across the world, and I hope this webinar is useful in your daily work stream, especially from the finance perspectives. So if you have any further questions and queries, please feel free to reach out to us so that we can follow up. So, but thank you very much, everyone, for joining this call, and we are looking forward to seeing you again.
Thanks a lot, and be on the lookout for the recording very shortly. Thank you.